Please give a warm welcome to Dr. Brett Cannon.
Thank you, Catherine. Just a quick thing. First, shout out to Google, my employer, for paying for me to come out here. I appreciate it. If you want to find me on the random social networks out there, you can go to about.me/BrettCannon, because that's only one line instead of 3 or 5 lines. Basically, the structure of this talk is I'm going to go over how import works in Python 3.3. Now, if you are using an older version, don't worry, conceptually everything I'm going to talk about is going to be more or less right. It's just semantic, exactly how the code works is not. But don't worry, it should still fall out and make sense. And without further ado, I'm going to get going so that I hopefully can get through everything. But to start, I need to go over some terminology. So there's something called a loader, and basically a loader does exactly what it sounds like. It loads a module. So this is basically the thing that takes a module object, sticks it into sys.modules, makes it become the module you're going to be working with, and gets it back to you when you run an import statement. There's also something called a finder, which basically finds your module. This is how Python is able to go, okay, you're looking for the OS module, where the heck is that on your file system? And in terms of finders, there's kind of 2 levels of finders. There's a path entry finder, which basically searches for modules in a specific location in the import path. Typically, this is sys.path or dunder path if you're looking in a package. And then there's also something conceptually called a metapath finder, which basically are finders on sys.metapath. I should give a quick shout out to Barry Warsaw, who rewrote all of the language reference for import and made them a heck of a lot more understandable, because Lord knows I had a hell of a time understanding what all that was about when I rewrote all this for import lib for Python 3.3. And I should say that up front, all this code you're going to see is more or less going to be accurate and is already in 3.3 in the import lib package. Before Python 3.3, import lib already existed, but starting in Python 3.3, import lib is the actual implementation of import, no longer the C code in import.c. So you can actually now look at the source code in pure Python and actually grasp what the heck is going on. So, to start, how the heck does your import call actually do something? Well, as you know, Python likes to really expose everything to you, so what really an import statement does is become an actual function call underneath the hood. So here's a basic diagram of how your call for a from import statement actually becomes a call to the dunder import function in the built-in namespace. There's basically 5 parts to it. It's a lot. So let's say you're doing from ... spam import flying circus. So any name between from and import, not including the dots, goes in the first part. So that's basically the name. If you're just doing import whatever, that whole part would go there. The globals of the place where you make the dunder import call gets passed in. The locals gets passed in, and these are all, as I said, the global state of the caller on the slide. This will make sense of why this happens later. There's the from list, which I will vehemently complain about later. Unless I'm really lucky and I take too long, in which I'll skip it and you won't hear me swear. That's what comes after import, in a from import, and basically it's just the little bits when you say like from foo import bar baz whatever. And then the number at the end is for explicit relative imports when you have those prefix dots to say, all right, look in this location of the package, look 2 levels up with 2 dots, et cetera, et cetera. If you just do a import whatever, that's always defaulted to 0, so it's known as, so it's explicitly don't have to traverse anywhere. So that's how statement goes to function. So what the heck does that function do? Well, these are the defaults basically, and we just pass on through and we get right into it. First thing, are we doing an explicit relative import, or are we actually know exactly full name of what we have? Basically, do we have to resolve the name of what we're trying to import and just infer it from where we're making the call? So let's say our index was not 0, thus it's actually relative import. How the heck do we figure out what we want? One thing I should mention about these slides, if you see anything in a red box, it's basically accurate, but I simplified it by just kind of cutting some corners a little bit, but it still makes sense. If there's a red arrow, I skipped an explicit step that import does, but for this talk, you don't really need to care about it. So that's why there's some red in here. As I said, for details, just read the source code for import lib. So, what do we do here? Yeah, or you just have me spend 6 years trying to make all this work and you just don't care. So what do we need to do? So as I said, when level's above 0, you're trying to do a relative import. So basically what you're doing is you're just splitting on the dots of the name you were given minus 1 level, right? Because 1 dot is level 1, but that's saying, all right, if I'm doing from dot spam import whatever, you're trying to do it in the exact same place you are in a package, so you really don't need to worry about that level. So what does this give you? If you use the package name that you were given, basically the dunder name of where you did the import, you can figure out basically what's the base position in the package. So if you were in foo.bar and you said, I need to go up a level, 2 levels, you'd split off and you say, okay, my base name now would be foo, all right? So if you have that, great. Now what you got to do is check. Did you do from dot dot import something, or did you from dot dot spam import something? So if name is defined, that's when you have to concatenate your base name with the other name, and now you have the full resolve name of what you're after. But if you didn't specify it, there's obviously nothing to concatenate, so you're just working right off of the base name. So that's great. Now what happens if index is 0? You do absolutely nothing, you just go with the name you're passed in. Much simpler. Unfortunately, we like to be crazy and support other things, so you got to go one way or the other. But that's how you figure out exactly what the name of the thing you're trying to get. This is how you get the explicit module name of what you want to import. With that figured out, you do a quick lock. If you attended my Python 3.3 talk, you know, at least in Python 3.3, locks are now at the level of modules instead of global. Beforehand, they were global. That's why this is a red box, not going into all the details. But basically, at this point, you need to lock down what you're working on so that you can deal with Sista modules and such that are at a global level for the interpreter. So, assuming, by the way, if you're not in Sista modules, which is obviously the nice result because it's cached and there's no work to do, what do you have to do to actually get something into Sista modules for you to use? Well, first you got to check to see if what you're working with is a package or not. Basically, is there a dot in the name of what you're looking for? If there is, you need to get the parent, because obviously you're going to want to work from the top. You're basically backtracking to where you need to find what you need to import. So if there's a dot, so you get the parent. If there's not, you don't have to really worry about anything. But if there is, basically, sorry, at the bottom you're trying to grab the path of the parent so that you know basically where you're going to be working from. If you're working in a package, you're obviously working off of dunder path. If you're working off of something that's not in a package and that has no parent, you're going to be working with sys.path. So now that we know what we're trying to look for and where, so we've got the full name, we've got exactly what paths we're looking for the import paths. Now we need to look through all of our metapath finders in sys.metapath, which is kind of the location in the sys module of finders that don't really have a concept of location. So there's a built-in finder there, there's a frozen module finder there, and then there's a finder that I'll discuss a little bit later in more detail that looks on sys.path. So we got our full name, we got our path, so now what do? Well, we ask this finder by calling its find module method, can you find me a loader to load this module? Do you know how to actually work with it? Can you find it and just do something? And basically just keep iterating through sys.metapath, asking, trying to find that loader. If none is returned, you get false, and you are great. If it's not, and thus you actually got back a loader and it's not none, fantastic. You now have a loader, you can actually make it come into being. So what do you do there? Well, you code load module with the module name. The loader will give you back a module, and then you do a quick check. Is there a dot in the name? Once again, is this in a package or not? If it is, you need to set it as a child on that package. So, you know, if you had foo.bar and you've imported that, you got to make sure it's on foo, so if you go foo.bar, that actually works. And then if not, there's nothing to really worry about. There's no parent to put it on. And then basically you unlock, and that's import. I am actually not kidding. That is essentially the loop of the actual implementation of import the function. It looks simple, and it basically is, but the trick is all those modules you stick on sys.metapath and what those do, and then how that cascades down into more detail. So let's go into some of that. So we'll start with the find module call, and we'll start with what's called the pathfinder. You can find it at importlib.machinery.pathfinder. And this will be the finder that you actually use that works with sys.path. So how does that work? Well, as I said, find module takes the full name of what you're looking for and then an optional path argument As I said, it's either going to be none if there's something specific, or actually a specified thing if you're working with something in a package, so like from dunder path. And then you start working with your defaults and figuring out what to do. So this is something new in 3.3 I should point out. We do have something called namespace packages. This is basically where if you have multiple directories on your file system, if you want to use concrete terms, and they all have the same name, they can get coagulated into a single package. So this is basically the canonical examples. If you got multiple zope packages and they all have multiple directories on sys.path, there's something /zope, something else /zope. They'll come together and all end up on dunder path. Well, you're going to have to keep track of some bookkeeping, so this empty list is going to come into play with that later. So let's say path was none. They're doing a global top-level import of the OS module, right? So path then is going to be none, and so you're going to have to make that sys.path. Otherwise, it's already specified. So what do you do with that information? Well, you start iterating through all those entries in your path, as I said, either sys.path or dunder path. And you start looking for an actual path finder, path entry finder for that entry. We keep a cache at sys.path importer cache so that we don't constantly rebuild these things, because basically, once you find a way to actually handle that entry, you don't really need to have to make that finder over and over and over again. Basically, if something can handle that directory, there's no need, it's a waste. So we cache it. So what happens if we're not lucky enough to actually have anything in there? Well, there's a whole other thing in sys module that you use called sys.pathhooks. And what that is it's a list of callables. And basically what you do is you take your path entry, pass it into each callable in sys.pathhooks and say, okay, can you find me a path entry finder that I can cache and use to try to find a module in this location? If it raises import error, it didn't, and you keep looping through. And if it ends up not working, you set none into sys.path importer cache, basically flag saying, there's nothing to cache here, don't bother looking here, just move on, try to find it somewhere else on sys.path or your dunder path. If you do, fantastic, you now have a finder, a path entry finder specifically, and you can use that to eventually get a loader, hopefully. And you cache that. So you've done it, you've cached it, fantastic, now you can move on. So, what you do with that finder is you now call, in Python 3.3, a method called findLoader. This returns a tuple of 2 items. One is the loader, and one is what we're calling portions, which is just a portion of a namespace path entry. So basically, if this finder, as I said, can't find a loader, it'll return none. If it returns none, then we check to see basically if it says, all right, I don't have a specific loader, but I at least found a directory or directories that could work for a namespace package later. If that gets returned, that gets added to that namespace path list that we had before and extends it. But if it found a loader, then we stop and say, okay, don't worry about trying to make a namespace package, just go on, give this loader back to import and work with that. And basically, you just keep iterating through every single entry in your paths, your import paths, trying to find what the heck could possibly have the module you're looking for. Now, in the end, if you don't find anything, but you happen to have some namespace paths that you happen to collect together, this is where you take the namespace loader and just return that as the loader that you're going to use to try to create this new namespace package, because you found, like, as I said, something /zope as a directory, and then some other place /zope, but no specific loader for zope itself. Otherwise, you completely failed, found absolutely nothing, and you return none, and you cry because you got an import error. And that is how you find something in Python. So, before was how import works. This is how you try to find something, usually on the file path, like sys.path. And now let's add another wrinkle. So, let's say your finder found you a loader, right? So, we can find it, we know where it is, how do we work with it? How do we make it do something? Well, that's when you want your loader and you call load module with it. So what I'll talk about in detail is the loader defined as importlib.machinery.source file loader, which basically uses the file system to load Python source. So load module is always called with the full name. And first thing you do is you try to get the module. either add assist.modules if it exists. Because basically when you do a reload, what it's actually doing is calling the loader for that module again and reinitializing it. If it's not there, you got to insert yourself into sys.modules, and then you move on, and then you start pulling together all the details you need for that module. So you need to get the file name, which loaders define as get under file name. You need to try to see where the bytecode would be, so that's imp.cache from source. You need to get the stats on a module. So in Python 3.3, this means you care about not only the modification time, but also the size of the source code. And then you need to then try to get the bytecode for the source. So, and as you'll notice, all of these, except for the imp call, are all actually defined as part of the loader API. So let's say there's some bytecode already there. How do we make sure we can use it, and how do we use it if it happens to work? So the first thing you need to do is you need to take the data you read and slice out the first 4 bytes and have a look at it and say, does this match the magic number for the interpreter? If you attended Larry Hastings' talk, he told you how the bytecode changes potentially between versions and we don't guarantee compatibility. Well, this is how we can tell whether or not this version is too old for us to consider using. Basically, the magic number gets incremented every time we make any change, and we know that basically if it doesn't match, we just give up and say, forget it, we're not even going to touch this bytecode, instead of going, oh, well, maybe, maybe not. So let's say that matches. Great. All right, has the source been modified since the bytecode was written? So now we check the next 4 bytes to look at the timestamp. This can be a little tricky because based on the granularity of your file system, you can pick up that change and sometimes you can't. This is unfortunate because sometimes file systems have a granularity of a second, and you can end up with a slight race condition, but usually this is not a big thing. Let's say that works. Okay, then we also check the size of the source code, just in case that granularity isn't quite there and good enough for you to detect, but you can tell that the file got longer. If all that happens to work, then what you can do is you use the Marshall module to then load the data from bytes 12 and on, and that'll get you back a code object. That's the nice case, because this is simple and you don't have to worry about anything else. Of course, being import, it's not always that simple. So let's say that the bytecode wasn't good for whatever reason. How do we actually generate that bytecode and then use the source for doing the load? Well, you read the source code using self.getData, just like you used to read the bytecode. You run compile. This is just a built-in compile, nothing special, with the bytes from the source code. The path to the source as an exec, and you don't inherit from where you're running because you don't want to use import libs, built-ins, and globals. It just wouldn't make sense. And then basically you just start generating the bytecode. First set of bytes is the magic number. After that, you add in the modification time for the source. You add in the length of the source, and then you use Marshall to dump it out to bytes, and then you just use set data off the loader to write it to disk, and then that's basically it. So either one way or the other, you've either compiled your code object that you need later using either the bytecode, because it worked, or the source, and generate the bytecode along the way. So that's what it takes to actually get from either to get your code object either from the bytecode or from the source. So with your code object in hand, you start building up your module. You got to set under file. You've got to set under cached. All the things which you've already collected up. If it's a package, which you ask the loader whether that's true or not. If it is, you set dunder package to the name of what the module is itself, and then you set dunder path based usually on the file to the source sliced off the file name. If it's not a package, then dunder package is basically taking our partition of the name and taking the first half. So this is either the empty string if it's top level, or basically just the package if it's the module itself. So with all that done, you set dunder loader to self, and you do the magical incantation of exec with the code object under the dunder dict of the module, and that magically makes the module happen. Yeah. You might think it'd be a little more fancy, It's not. That's literally it. You can do this yourself and at the interpreter prompt with no problem. It's nothing fancy at all. I mean, this is why when you do module imports, you have side effects. It's nothing more than execing a code object using the dunder dict of a module as the global namespace. And this is one of the magical things I think a lot of us love about Python is a lot of stuff's just very straightforward and it just works. This is why it just literally runs the code top to bottom. This is also why, by the way, you have the if dunder name equals dunder main. This is kind of why, because it's literally just executed code and it just runs that if statement at the bottom and just figures out based on what dunder name was set to earlier what it should do. So the loader's done all this work and now you got a module. Yay, you'd think this would be over, wouldn't you? No. Now we deal with my not favorite person in the world, the from list. Yes, it's good. This actually turned out to be a really tricky corner of import to implement. So I'm very bitter. So, from list. Let's go with whether or not you have from list set to anything, right? Whether it's an import whatever or from something import whatever. All right. If it's true and there's nothing there, in the simple case, what do you do? Well, first you got to quickly check if index is equal to 0 or not. Basically, as I said, whether it's a relative import or an explicit import, because you have to choose what to give back from import. Because remember, if you've noticed, if you do import a.b.c, you actually get back the package A. So that a.b.c in your code actually works. Because you can't return a.b.c because, well, okay, well then how the hell do you get to the A? Because remember, this is just a function call return. So if it is 0, that's why you have this partition call to get basically the very top parent package. And then that's what you pull out of sys.modules and return. This is something some of you do that drives me a little nuts. You actually pull out something. You don't put what you import into sys.modules. You decide to do something fun and select something you want into sys.modules. So you actually have to make sure you actually pull out of sys.modules itself for what you're importing. Let's say it's not 0 though, and you're actually doing a relative import. Once again, if you're doing from whatever import something and it's relative, you got to realize you're working off of like from ... spam, you want that spam name to be what's bound in your namespace, in the global namespace of where you're doing the import. So this is what all this is about. Basically, if you specified a name, you've got to care and slice off to the name to the first dot in the name. Basically, the relative parent of what you specified. And then if you didn't specify, you just return whatever you found. Now that's the simple case. Yeah, I heard someone snicker. It's true. It's ridiculous. So let's say you have a from list. You did from something, import whatever. So what's the first thing you gotta do? Well, first you gotta see if you specified it under path. If that's true, now we gotta check for import star. Something we all think is evil, but we all admit we've done at least once in our lives, and we've repented for the rest of our lives for it. So what do? You look for dunder all in the module namespace of what was imported, and you basically use that to extend the module and basically ditching the asterisk. So that'll at least get you exactly everything you're trying to import, whether it was exactly specified or you said star. Okay, so with that specified, now what do? Well, now you go through from list and you look for everything specified there on the module. So you do a has adder check. If it's not there already, because remember, it could be a module, it could be a class, it could be an attribute, who the heck knows? You try to do an import basically, if it's not there, because you got to assume, for instance, if it's off a package, it might be a module, so you got to care. So you do an import. If it fails, okay. You basically just ignore it, because what ends up happening is your import failure isn't here. It's actually done by the bytecode by the interpreter later on. So you just basically keep iterating through one by one all the way through and just checking, is it there? If it's not there, try to import it because it could be a module. If it's not, then I just don't care and you move on. And then with that, you're finally done. And you return your module and you're happy and you don't get your import error and hopefully you move on with your lives and do something better. But to give you an overview of what all this breaks down to, so that's how to deal with from lists and just from lists. And this is basically a rough overview of import. From import itself being on the right-hand side, that column from top to bottom, that's import the literal algorithm. The upper left corner, once again, is import.machinery.pathfinder for the sys.metapath entry that knows how to work with sys.path or packages. And then in the bottom left corner is importlib.machinery.sourceFileFinder, which knows how to read off of the file system, how to read from source or from bytecode. And that's all I got, and I will take questions. I think we have a mic there if anyone wants to ask. And I don't bite, don't worry.
If you wanted to do silly things like synthesize modules as they were asked for, or load them over HTTP, where is the right place to hook into this machinery?
So there's two levels to this. Basically, you're going to put it probably either on sys.metapath or something on sys.path hooks. So it really depends, is there a concept of a location? So if, for instance, let's say you tried to import over the internet using HTTP, right? So what you would do is you would stick a URL on sys.path, and you'd create something on sys.path hooks that would recognize that it's a URL, and then return you a finder that would understand that, okay, if I tried to hit this URL, I know how to do a REST call, do like a header or a get or something, check that it exists, and then it would return a loader, which then understands that, okay, with this URL, I know to do a GET request to get that source back. Now, if it was something more generic that didn't have a location, you would put it on sys.metapath. So basically, anything that's got a concept of a location, you'd write something for sys.path hooks that understands locations and knows whether or not to work with it or not. And then if you don't have a location, you put it on sys.metapath. Does that make sense?
Can you use a from dot from a top-level module?
No, that's an error. That's why there's a red box around that part. Basically, we actually do a check to make sure you don't try to index out, because obviously that's a major security hole. If something you can just go, all right, I just want to see how high I can go up the directory based on how I do an import. So we do a check to make sure that you just can't go past it. Thank you for the documentation, Barry.
Well, I was just going to give a plug for the documentation. Great talk. Thank you very much. So in Python 3.3, if you actually look in the language spec, how the import system works is fairly elaborately documented and hopefully clearly.
I had to touch it the other day, and I believe it was.
Oh, great. OK, so go there if you want more information.
Yeah, basically, if you really want the nitty-gritty details, that's not as a flowchart. You can read the docs. The reference, the language reference has a really good, clear definition of what it works or not. If you just want to know how to work with this stuff, import lib. I've tried to make sure the APIs are simple enough that if you want to do something special or different, there should be very, very little code that you have to write to make it happen. I've tried to make the abstraction levels reasonable such that if you want to do it through a SQLite database, it shouldn't take a whole lot of work to do that. Or even if you want to do an alternative version, like some funky DSL that you want to work with, that's also very easy to do. So import lib docs if you want to learn how to do crazy stuff with import. Reference language reference if you want to know the exact nitty-gritty details of how the whole system works.
Yeah, so let me just say one other thing. Import lib sounds like it should be really scary, but it's really not. Brett did a great job. For example, the PEP 420 namespace work was really not that difficult to do especially because import lib, having the import system in Python, really great job. So thank you, Brett, for making this sing.
Hi, can you explain how import something as something translates to dunder import call?
So basically, for those of you that don't know, if you do import from something, import whatever, or import whatever, you can always tack on an as something to basically rebind the name of what you use in your global namespace. So if you just hit import OS as gobbledygook, gobbledygook would get set to the OS module. It's literally nothing more except bytecode that basically just does an assignment. It literally gets the module back, sticks it on the top of the stack, and it just goes store. I think it's literally just a store global, whatever to that name. It's really nothing special. It has absolutely nothing to do with dunder import. It's more with the eval loop and the bytecode. Yes.
Yeah, so you talked about this loading bytecode. Does this change significantly if you're loading C extension modules?
No, so basically, so the way it works is basically, if you look at import lib, there's an import lib.machinery. I believe, file extension loader or extension file loader. It's extension file loader. And basically implements the API as you would expect, except the load module call just basically knows how to work with Python to basically dynamically load the .so file or .dll, depending on your OS. But basically, replace the source file loader, and the code obviously is different because it calls a different C function, but basically everything else works the same. So Pathfinder knows how to identify what's going to be extension, knows that it exists on the file system, and knows to return that specific loader for that location instead of source file loader. So the concepts up to the loader point are exactly the same. Yep.
So our build box is completely automated, and unless the developers are naughty and install some packages on it, we have to wait sometimes to get packages on there to run our tests. Mm-hmm. And so what we do is if we want to test something right away, we import sys, do sys.modules, put a package in there and mock it.
Okay.
Is there a better way to do this, like with sys hooks or something like that?
So basically, you just want to get something in there faster than you get pushed out to your pushed out to production.
Well, to our build, well, we have multiple steps. We have like QA and things like that, but just to get our PMs out to make sure the whole build process besides the test work.
Basically, how do you stub out a module before it actually comes into existence?
Yeah.
So one thing you can do is if you set something up on sys.metapath to basically go, okay, if at the very end of it, and just go, okay, I got all the way to the end. None of the previous entries on sys.metapath worked, which includes what you would call basically default import. You could have that return something. You can either whitelist it or just say, for anything, automatically just return this new blank module or whatever you would want to mock, and that's where you'd put it.
Okay. Thanks.
We need to be done first.
Okay.
We're out of time.
We're out of time.
Do I get a question?
Turn the mic on.
Okay.
You can catch me and talk to me and ask me questions later.